So the worked example that we're going to look at is a paper by Stephen Levitt from a few years ago now. And what Levitt looks at is the effect of police on crime. Now, it may sort of seem obvious to you that there should be an effect of police on crime, but it's perhaps not obvious on second thought. And that's because, well, how many police officers would we need in a world in which there was absolutely no crime? The answer, of course, is that we would not need any police. And so it may be that we have more police only when we have higher rates of crime. And so if we just analyze the data, it could be that we find a positive relationship between police and crime, which is sort of a really great opportunity to use instrumental variables. And so what we need, remembering from our assumptions, is we need a variable that is affected, that is correlated with the number of police, but that is not, in and of itself, related to crime. And so it's difficult to sort of find variables in this case, but Stephen Levitt suggests that, well, actually a good candidate is the number of firefighters in a city. And so he argues this because he thinks that they're relevant because cities that have a large number of firefighters are also likely to have a large number of police just because of the types of cities that they are. He also shows some evidence that looks at a regression correlation between the number of police officers and the number of firefighters in the city, and he shows, well, look, they're highly correlated. And then in terms of the exclusion restriction, he doesn't spend an awful lot of time justifying this, but he does sort of make some arguments as to why they should not have a direct effect on crime, namely that they are fighting fires and not criminals. However, he does acknowledge that there's going to be some common factors, and so he makes his regression slightly more complicated to try and adjust for this. So the data set that he uses is 20 years worth of data of a whole bunch of US cities. And of course, he provides a nice summary statistics table for his variables. And so you can see police per capita and firefighters per capita. These are our two key variables. Police per capita, firefighters per capita, and violent crime per capita. These are our key variables, and then we also look at a couple of other dependent variables, property crime per capita. There's a bunch of variables that Levitt adjusts for, and so some of those are in the regression, in the summary table as well. The model, he writes out his model, and so he says that in the first stage, we're going to say that the number of police is explained by the number of firefighters. And so this is that part of the model, and then after that there's a whole bunch of other variables that just adjust for various city and county level effects and things like that. So once we have that equation estimated, then we use that forecast to itself explain the amount of crime. And again, that's the important part of the regression, but there are a whole bunch of other variables that are being used to adjust for things. And so the typical way that authors present their instrumental variables results is to show both stages. And so this is what we see in Levitt's table 2. And so the dependent variable is police per capita, and the independent variable that we are most interested in is this firefighters per capita. And so we can see that it is small, but it is positive. And so as the number of firefighters increases, the number of police also increases. And so then after we have after we have that, then we use that equation as a input to our instrumental variable equation. And so in this case, we're looking, the dependent variable is violent crime, and we're explaining it based on police per capita. And so our instrumental variables estimate is that there is a negative effect. And so that is great. More police does in fact reduce the crime rate, and so that's fantastic. You will notice that we have some fairly wide standard errors on this estimate, and that's fine, but it does sort of, Levet goes on to say that, well, we should look more at the magnitude, we should look more at the direction, the negative sign on this estimate, rather than the magnitude itself. And we can see that this magnitude, that the negative sign is negative for both violent crime and also for property crime, and so that's great. It's interesting to compare the instrumental variables estimate, which is in these third columns and sixth columns, with the OLS regressions. And although they're similar, they do differ slightly in terms of their magnitude, so that's interesting and shows the value of using this instrumental variables approach. So I want to make a few brief comments, mostly to do with open science and things like that, in light of the Stephen Levet paper. So he finds that there is a negative effect of the number of police on the amount of crime, and so that's good. But it's fairly remarkable just how reliant the results seem to be on the various model specifications. The results bounce around a whole lot. You can see that just in those results tables, and these are the results that he actually published, right? You can imagine how many results there are that he didn't publish. And so this is certainly a paper that just screams out to be reanalyzed because of this. Levet also does fairly limited model validation. Perhaps it's just more that we are more aware of these sorts of concerns these days, but it seems to me like there's definitely going to be a whole lot of overfitting going on here, and we might like to have another look at these estimates in the context of a more modern approach. And the final and most important comment that I'd like to make is that this paper, Levet 2002, is actually a response. So 5 years before this, the original paper was published, and then that paper attracted an awful lot of attention, and it turned out that a few people tried to reproduce it, including one particular author, and this author found that there were actually a whole bunch of issues with the paper. And the only reason that author was able to find that there was issues with the paper is because Stephen Levet shared the data and the code. But what if Stephen Levet hadn't been decent about providing the data? We possibly would never know that there was these issues with the paper results. Or what if we couldn't follow the code? To a certain extent, of course, this paper was published, more than almost 20 years ago. And so it's sort of nice to see how far we've come, because this would simply not fly these days. You have to publish your code and data these days. We wouldn't have to ask for it, and we've seen plenty of examples in this class where we have actually gone and reproduced people's analysis ourselves. But it really does reinforce just how important this open data and reproducible science business is. We would never have known of these issues in the original paper, but for the fact that Levet was kind enough to give this other author his code and data. So it's very important. So in the final section, we'll just make some concluding remarks.